Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program brought to you by Techstrong, GitLab, and AWS. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation ahead. First, I need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and I'm sure you will, we want you to send those in to us using the Q&A tab. You can find that Q&A tab on the right side of your screen, along with a few other options. Over there, you'll see the chat tab, and we'd like you to use that for more general comments. So any feedback from what you hear in today's presentation, or if you'd like to start warming that up now and letting us know from where you are joining, we'd love that just as much. Also, before we close out, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of our program. So our topic today is mobile DevOps with GitLab and AWS, and we're going to be having 2 different presentations, all in one from GitLab and one from AWS. And I'm joined today by Lee Faust, who's a global field CTO at GitLab, and Mark Kriaf, partner solutions architect at AWS. So Lee and Mark, thank you both once again for joining me on Techstrong Learning. Mark, do you want to get us kicked off?
Yeah, sure. So Cody, thanks for having us here. Hello, everybody. My name is Mark Kriaf. I am a partner solutions architect at AWS. And we'll start today talking about Amazon EC2 Mac instances. So without further ado, let's go into the first slide. So let's start by reviewing the key challenges with building Apple applications today. The overhead of managing on-premise fleets of Mac servers creates physical, operational, and cost inefficiencies that take developer time and resources away from doing what they do best, which is building creative and useful new app releases. In most cases, customers are having to manage separated build environments for their macOS development pipeline from their Android and Windows builds, and this adds operational complexity and creates security risks. Lastly, lifecycle timelines are limited by available infrastructure. During times of peak demand, test and build queues might be affected and delayed, essentially delaying our application time to market. All these challenges together lead to physical and operation overhead that gets in the way of innovation. So let's take a look at what EC2 Mac instances customers are sharing in their public testimonials. With the ability to provision and access macOS environments within minutes and dynamically scaling capacity as needed, EC2 Mac enables faster time to market with new innovative applications. Customers reported 4 times reduction in build times, up to 3 times increase in parallel builds, up to 80% reduction in machine-related build failures, and up to 50% reduction in fleet size. Another benefit is the ability to easily customize, distribute, and deploy macOS images with simple API calls. With EC2 Mac, Apple developers can now focus on code and not infrastructure management, and leverage the breadth of AWS services available. Developers can seamlessly migrate their pipelines and get to work regardless of where they are, thanks to global AWS infrastructure. And they can configure for high availability and geographic redundancy that was not possible in an on-prem setup. Overall, customers such as Intuit, Pokemon, NBCU, and Flipboard leverage EC2 Mac, and they report that can now spend more time focusing on application development and improving the user experience. Let's go over some of the key benefits when we talk about Amazon over EC2 for EC2 Mac instances, starting from the left. By bringing Apple application development pipelines to EC2 Mac instances, our customers are benefiting from fully managed, scalable Mac infrastructure, enabling builds to run concurrently and delivering new apps faster to market. Next is the ability to unify their DevOps pipelines. With the availability of Mac OS on AWS, Customers can kind of consolidate their application pipelines and application pipelines for Android, Windows, and Apple into a single environment, which we'll go over later on in Lee's part also. Eliminating fragmented development, and this allows us to essentially accelerate the pace of innovation. The third part is amplify developer productivity. During the development of EC2 Mac, one of the goals of the EC2 Mac product team was to make sure that the customer experience and features for EC2 Mac looked and felt exactly like any other EC2 instance. With EC2 Mac, customers can get the familiar EC2 interface combined with the integration to services like EBS, IAM, S3, and CloudWatch, and enable developers to seamlessly migrate their pipelines to get and start working essentially. Lastly, by making macOS available in AWS around the globe, we enable developers to build and test Apple applications from anywhere so they can stay productive regardless of their location. And I want to focus now on three main benefits that we got from feedback that we asked our customers about EC2 Mac instances. The first benefit is the ability to eliminate resource bottlenecks and resource wastage. EC2 Mac instances are available on demand and can be provisioned and launched within minutes with a simple mouse click or a set of API calls. Enabling to quickly scale up macOS capacity based on workload requirements, and you're no longer needed to over provision or purchase for your peak requirements. With EC2 Mac, you only pay for what you use and minimize resource wastage. Second, the ability to simplify macOS maintenance across your Mac build fleet. For launching instance, EC2 Mac offers Amazon Machine Images, or AMIs, for Big Sur, Catalina, Mojave, and also future releases. In addition to macOS, these images also include EC2 system monitoring, AWS Systems Manager agent, and the latest Xcode command line tool, making it easier to launch an EC2 Mac machine and get started. One of the recommendations that we give our customers is that they can customize their own set of derivative AMIs with specific software, such as version of Xcode that they need and tools that they require. Those customized AMIs can be both shared and launched directly from the EC2 Mac interface with the exact same configuration stack that you need for your software. And lastly, global availability. EC2 Mac is available in regions across the US, EMEA, and Asia Pacific. And because EC2 provides at least 2 availability zones per region, you can have the confidence of regional redundancy across AZs. So this was a very high-level overview of the AWS, Amazon, or EC2 Mac instances. And with that, I want to go forward and invite my friend Lee Faust from GitLab to talk a bit about how GitLab plays within this partnership. So Lee, take it on.
Great, thanks, Mark. Let me go ahead and share my screen.
I need to stop mine 1 second.
Okay. So the reason why I thought this would be very interesting today is I was in a meeting about a month and a half ago with a joint customer between GitLab and AWS, and the customer came and told us a very similar story. They currently have 40 Mac Minis that sit in a closet in their environment in New York City. And they've started growing their iOS and Android development teams globally. So they've got teams in Singapore, in India, and in the UK who all needed access to this infrastructure. And as they started doing that, they started finding that people were installing things on these Mac Minis that was causing inconsistencies across their builds. As people were installing different things, they also realized that people were going ahead and provisioning new resources in those machines that were causing issues with existing builds that were taking place. So they came to AWS and GitLab and they said, can you help us solve this problem? They've looked at other cloud providers, they've looked at the other cloud providers' offerings, and they thought that AWS had the best offering in the market. So what we did is we went through and I explained to them how Mac instances work. So the first thing that you have to do is, this is a little bit different than when you're going off and configuring generic EC2 images. So the first thing you have to do is you have to create what are called dedicated hosts. So when you define a dedicated host, this allows you to be able to segment the number of virtual CPUs that you want to allocate to any specific AMI. By default, every AMI that you're going to provision will by default consume every virtual CPU that exists inside that dedicated host. If you want to be able to provision less virtual CPUs, then what you would want to do is in your configuration, whether you're using Terraform or you're using the CDK, whatever it may be, you want to make sure that you're allocating the right number of virtual CPUs for that particular AMI when you create it. So then what you're going to do is you're going to provision your AMI into that EC2 image. So here I'm choosing macOS Ventura, the latest version of macOS. I'm giving it a name. And what you'll notice in the bottom right-hand corner is you have to define the target host. So here inside the target host, I'm telling it which one of the, I'm telling it that I want to use a dedicated host. I'm going to target the host by ID and then the host ID from the dedicated host that we just defined earlier. So when you go ahead and you do this, you can define other additional metadata. So you can create a larger storage volume. You're not limited to just the 100 gig like I have here. This depends on the things that you want to define inside of it. Now, one of the items that I've realized is, there's sort of two different trains of thought, and this would really depend on your environment. Are you interested in creating a lot of smaller Mac OS images, maybe 2 virtual CPUs in each one? Or do you want to create one larger one that consumes all of the virtual CPUs and then virtualize it on your own? So both of those can work with GitLab. If you do the first model, where you're going to create a lot of different smaller images, what you would do is you would use what's called the shell GitLab runner model. In the model that I'm going to describe today, where I consumed all of the resources in that dedicated host, what I did is I actually virtualized it myself. Part of the reason why is because, number one, it makes for a better demo. And number two, it makes it easier to explain what's actually going on behind the scenes. So once you've provisioned your Metal instance, it'll take a little while. So if you go out and you read any of the different docs that are out there, it'll take probably somewhere in between 8 and 10 minutes before the instance actually becomes live. So it will tell you inside the EC2 console that it is up and running, which anybody who knows this, that anytime you boot a Mac OS instance, as it goes through its pre-boot process, it is actually available. But the services inside of the macOS instance are not, you do not have the ability to actually interact with them yet until the entire web UI has actually come up and is running. So what I did is, using my PEM key, I was able to create a tunnel between port 5900 on my localhost machine and mapping that back to the EC2 image that ended up getting provisioned. So once that's up and running, I can see that I am SSH'd in. That port is now mapped. So I've got a secure tunnel. And then what I did is on the bottom right-hand corner, I used the macOS screen sharing software to go ahead and connect to that particular instance. Once it's up and running and you log in, you might ask, wait a second, how do I know what the EC2 user's password is? Well, one of the things that if you read any of the documentation, what you'll need to do is before you can actually log in to this particular instance, you will have to SSH in, and you will have to sudo in and set the password for the EC2 user. Once you have that password set and you own it, then you'll be able to log in through the web UI. Now, once it is up and running, what I did is I then virtualized this hardware image that ended up getting created. So I installed Parallels on the host machine, which we configured through EC2. And running off of Parallels, I ended up setting up another macOS image. Now, when you think about doing this, there's, again, those trade-offs. The one thing that's nice about setting up CI runners is you can have different CI runners per application, or you can create what we call runner fleets to be able to run off of a single instance. Now, you'll notice inside when I configured this GitLab runner, you'll notice on the very top left-hand corner, so I've got this concurrent is set to 1. So what this will do is if I've got a shared runner that is configured for, let's say, a group or a subgroup inside of GitLab, it will only allow one of these VMs to be created at a time. If I wanted to create multiple, I could set this concurrency level, but you're going to want to do some division. So if I've got my VM that I am setting up inside of this Parallels instance, you need to do the division. So if I'm telling each VM to be 2 virtual CPUs and 4 gig of memory, the maximum concurrency level that you're going to want to set is 3. Now, you can go off and have multiple different AMIs and provision multiple of these, so that way you can share them and have many different runners configured across your group or subgroup, or even allocate them to specific instances. Once this is up and running, I've got my runner configuration where you'll see that I've got this token that gets created. This token right here is going to map to a linked clone inside of the image. This is going to get created automatically when GitLab instantiates this particular runner from GitLab because a new push has occurred. What you'll be able to do is this linked clone, you can have multiple of these linked clones, and it will create snapshots of them. The reason why it's going to do this is so it speeds up the configuration of the next run. Anybody who has ever done anything with GitLab in the past, you'll know that there are caching mechanisms for artifacts and for resources that we will want to make sure stick around on that VM so they don't run every time. One of the things that will happen is you'll run into an issue when you try to, it connects to the VM over SSH. By default, this disable strict host key checking is set to false. So you will want to set this to true. Otherwise, what happens is when you SSH in, the macOS instance is going to give you the do you accept the key pair, and it will sit there and fail because it's unable to connect over SSH. It will time out. So by setting this key checking to true allows you to automatically connect by passing in the Y automatically. Now, inside of GitLab, once you've run the GitLab runner command from the host of the Mac Metal machine, you will then be able to see inside your projects, you will be able to see group runners. So what I did is I configured this particular runner to be executed at the group level inside of GitLab. You could set this up to run at a specific project. So you could take the token from the project and share that with a GitLab runner and configure it that way. So only certain VMs run for certain projects. This shared allows me to have multiple projects that I want to create consistent builds across multiple projects inside of GitLab. And then also we could have this where we could have multiple different Mac 1 metals that would connect over a shell. Now, the thing that's interesting is here, you're going to notice that this particular runner ID is still the same token ID that we saw here. This is how you know that the two are going to be mapped together, so you'll know where it's going to run. The other thing that I did is I created tags for the specific images. So another thing that you could potentially do is you could have it where you could have just specific runners just for iOS development. You could have other ones just for iPad OS. You could have other ones just for Mac OS. And then you would tag your particular CI files with the tag of the runner that you want to execute as part of those group runners. Now, when we set up our GitLab CI file, our GitLab CI file is going to use something called Fastlane in the background. And what it does is this is going to run in a build stage. What I need to do is they will tell you in the Fastlane documentation that you shouldn't use the built-in Ruby, the system Ruby, that is on your Mac base images. So what I did is I installed ASDF, and the way that I get ASDF to load once I SSH into the instance, I had to source the ZSH to load ASDF, so I got the right Ruby and bundler so I could install the dependencies for Fastlane. Now, once I install all of the dependencies, I'm now going to set up the Apple Issuer ID. So this is from the Apple Development Center. And that is then going to tag back and pass that Apple Issuer ID to Fastlane to be able to go ahead and do my build and deployment. The tag underneath here is telling me to go and find a shared GitLab runner that is associated with the tag iOS. So any GitLab runner with iOS in it will go ahead and run. This is really powerful because if I had, let's say, 20 Mac OS Mac VMs from AWS, and every single one of them had the ability to go ahead and connect, all I have to do is set every single one of those to a tag of iOS, and I can share all of those runners inside of GitLab. And GitLab it'll try to find any one of those that are available across those different images. Now, things that are really interesting with these tags is, let's say I've got a runner fleet that I have set up inside of APAC for my Singapore and India teams. I've got another set for Americas, North America, South America, Canada. And then I've got another one for EMEA, and I've configured those. I can now have tags for iOS with a region, and now I can separate the tags. I can say iOS, EMEA, and what it will do is go and find those particular runners in that region, so that way I am running all of my builds off of the images locally to wherever I live. So we're not having to worry about cloning things all over the globe. I can go ahead and clone them specifically to the region where the runner is going to go ahead and execute. Other things to be aware of are when you go ahead and do these builds, it might also be important for you to have different locales. So you might want to make sure that all of your builds, all of your executions are done in language, so that way the logs and everything that come out, people can read where the errors are occurring in their native tongue. Same thing, you need to set all of that in the base images, so that way the locale is loaded for the build, so Fastlane will report back in the language that you want to execute under. So inside of GitLab, once I go ahead and I do a build, we also have the ability through these configurations to be able to do things like run SAS testing. So currently we have a development preview. So as part of my pipeline, I could do a build, and that build will also go ahead and do a deployment into the Apple Development Center. And then I can run my SAS testing against it. I can even deploy my IPA into the AWS Device Farm. And when I have that configured, it will go ahead and automate all of my DAS testing. And if that succeeds, then I go ahead and I get a little green check mark. If it fails, I will get an error report back from Fastlane that would be viewable directly inside of GitLab for me to go ahead and see where that error actually occurred. So once you go ahead and you have all of this configured, this is really powerful. So going through Fastlane, what I've done is I've configured all of my certificates and my profiles. So once I've had my profiles and certificates configured, there is something inside of GitLab. If you're using Fastlane today, there is something in GitLab called, it is a secure storage mechanism for all of those certificates. So it is something that somebody, if they clone the repository, they are not going to see. It is something that is stored as a sort of a secure vault inside of GitLab that is only available to this specific project. So once I've got those certificates and profiles, and you'll have some for development, you will have some for the App Store. When you go ahead and you do your builds, there is a special configuration in Fastlane that tells it to set up CI. When I tell it to set up CI, what I'm going to do is I'm going to enable my certificates to be available only in read-only mode. What that will do is in read-only mode, it is going to validate the certificate and the profiles that are stored in GitLab in your project with the certificates and profiles that are currently sitting in the development center for Apple. It will not update them. It will not change them. It's telling them to validate that they are identical. And because they are identical, it can continue with the build using that specific certificate and profile. Now, once that build takes place and everything goes through, it will take those certificates, go through the build process, create the IPA, and then it will publish it back into test flight. So when you go back into test flight, what I can see here is I can see a new version of the build. So there is a build number incrementer. And when I look at the build incrementer, I get the build number plus the build. And then what will happen is anybody who is registered as a beta tester as part of test flight will get an email that tells them, hey, there is a new build available. So here's a screenshot of test flight on my personal iPhone. And I've got test flight set up. And here I can see that I have an application called File Editor. And that file editor, I can go ahead and I can update it. You can see here the parentheses version. This is the latest version of File Editor. This is all happening right now inside of a merge request. So because it's happening inside of a merge request, we can do things with our GitLab CI file that I can tell it, hey, because I am in a merge request, what I want to do is I only want to push to test flight. Once I go ahead, I can even get the status. There are some things on Fastlane, as well as some custom items that you can download to run as Docker images, that you can go ahead and do tests to be able to see if what the feedback is from the users. You can get that feedback as part of your pipeline, and once it has been approved and a merge takes place back into your main branch, we can then have a custom build that happens again with all of the changes from multiple different people. And that particular main change will now go ahead and submit directly to the App Store for review. So you can go all the way from build test into something like AWS Device Farm, run all of that completely automated. As long as all of that succeeds, I can then push to test flight and allow people to test it individually. Let them test it, provide their feedback. Once they've provided their feedback, they can go back in and accept those particular changes. As long as all of those changes have been accepted, then you can go ahead and merge your changes and create a build that would then go into the App Store for people to go back and now make it readily available for people to update on their iPhones as part of that change. This is really something that I think is unique in the industry, because I can now have these runner fleets for follow the sun development, allowing me to be able to merge these changes together, allowing for synchronous builds, so I can make sure that my build ID is constantly being updated across different versions, and making sure that people are aware of changes that are occurring to know which version of which build they are currently working off of. So I hope that this encourages you to go off and look at how you can go ahead and use GitLab with the CI runner architecture and using AWS for iOS development to be able to do your build, test, and deploy applications into production. So with that, I thank you, and I'm going to go ahead and stop sharing my screen.
All right, so we have entered the portion of our program where we will be opening up for Q&A. So to our audience, if you do have any questions for Mark and Lee, now is your time to send in those questions. We've received a couple so far, so let's just go ahead and take these from the top. Our first question reads, so in regard to iOS development, how different is iOS dev from developing for Android?
Wow, what a great question. So obviously the languages are very different. So inside of iOS, today most developers are going to be using Swift for their iOS development. Inside of Android, you're going to use Java and Kotlin. Now, inside of iOS development, you need to do a build on a Mac machine. This is the primary reason for having this particular webinar, is being able to have a partner like AWS who can go off and provision these for us on the fly is really important. When we talk about doing Java builds for Android, we can use generic Linux EC2 images, but we could also follow the exact same paradigm. I could either create smaller EC2 images to go off and do my builds. And back to Mark's point earlier, one of the things that is a best practice is taking your development environment, all of the dependencies that you're going to need, put them into an AMI and then, or into an EC2 image, and then create an AMI out of it, so that way you can build reusability. Then what you can do is share that across the different development teams, so that way everybody is building consistently whether it be for Android or for iOS. Now, once you learn how to use something like Fastlane, you'll learn it. For me, it's actually more difficult to learn how to do the certificates and the profiles for iOS, iMac, or iPad OS. It's more difficult in those environments because the rules around building applications for Apple's ecosystem is much more stringent. It's very strict. Where on the Android side, it's a little bit more flexible. So Fastlane also has the ability to build pipelines that we can use inside of GitLab for being able to do Android development with Fastlane as well. The difference is all of the configurations that you need around your certificates and your profiles are not as stringent.
So it looks like we did get an immediate follow-up. So any luck with using Mac OS clone or emulation on non-Apple hardware?
So I can take that. So license-wise, you cannot do that. So there's restrictions from Apple in terms of Mac OS licensing that doesn't allow you to run Mac OS on non-Apple hardware. And same goes for the length of time that the machines are provisioned for. So the minimum unit is not seconds like other instances in AWS. It's 24 hours. So it doesn't matter if you use it for 2 minutes or an hour, you're billed for the first 24 hours. So this is also something to take into consideration. There's more information obviously on the Amazon website in terms of what you can and cannot do with Mac OS instances, but that's in a nutshell.
Yeah, and Cody, to tag on to that as well, when it comes to the development side specifically, Apple will have specific markers against how a particular machine was run. Even if it's run inside of a VM, it actually knows the host that the VM was running in. So it will report back that if you tried to go through the App Store process for an approval, they will reject it because they will see that you built it on non-Mac hardware, which is a big no-no. And if you have existing applications, I've had rumors of some other developers that have actually had their apps removed from the App Store because they tried to get around that particular requirement.
Awesome. So while we're on this this note of the difference between Apple's tool chains and whatnot, so how is what you've demonstrated today different from the tools that Apple provides?
Yeah, another great question. So Apple has recently, with Ventura and the latest Xcode, they now have what they call their, I think it's Code Cloud or something along those lines. The thing to remember is Code Cloud is, or Dev Cloud, whatever it's called, what it's going to do is it runs from still a local Mac OS. One of the other things, the customer that I was talking about earlier, one of the things that was very interesting to me is their iOS developers don't even have Macs to be able to build off of. Their standard machines that they get to work off of are Windows machines. So one of the things that we went off to be able to prototype out of this process was being able to use screen sharing with a Mac OS machine where they could go ahead and do their development in the cloud as well. So they could use the remote desktop and they could actually do their builds in the cloud and then using GitLab to be able to build off of shared instances off of that. So with that, you have to run all of those different CI jobs, everything else. It's all going to be managed and configured from Apple. So like things like being able to use Fastlane or being able to use other things where you want to be able to get some sort of economy of scale, you're not going to be able to do because it's going to use standard pipelines that are created and managed by Apple for your builds. So it makes it difficult for you to be able to create things like reusable templates, being able to have shared dependencies at the root OS level. Those kinds of things are not going to be made available to you because it is a SaaS service from Apple. It is not something that you would manage and be able to run on your own. So if you needed to test against previous versions, things like that, that would be very difficult for you to be able to do.
Awesome. Thank you so much for that. Our next question reads, I believe this is about your examples in the presentation, but was the AWS automated testing happening on real devices, and how?
It is happening on real devices. So when you go into the AWS Device Farm, you have to go in and you have to create a template. And with that template, you then define the number of devices that you want to test across. And those different devices can be both iOS and Android. And you define which versions of which screen and which OS you want to run. So I could say, okay, I want to test against iOS 14.1, 14.0, 13.1.2, whatever versions of iOS I want to run against. All of those machines will be pre-configured with those iOSs. And then I can also test against permutations of, oh, I want this to be an iPhone Pro Max. I want this to be an iPhone Pro. Then I can go across different versions from 14 to 13 to 12. Those things are all really important to be able to test against because, as we all know, like in the latest version of iOS, you have the new island that happens up at the top, but it's only available on iPhone 14. Well, you want to make sure, just like in any sort of code that you write, you want to make sure that if somebody doesn't have an iPhone 14 and you're building functionality that's going to leverage that island, you want to make sure that if they don't have the island, they get the same data, just in a different way. So those are the reasons why you're going to want to be able to have these types of automated testing in something like AWS Device Farm. And those types of configurations allows you to be able to plug those things directly into your pipelines.
Yeah, and it also really streamlines the whole process. Instead of managing all those subversions on your own, it really streamlines the whole process from that perspective. Makes it easier for you to test on multiple devices, on multiple versions also. So yeah.
So moving on to the next one. What is the minimum instance run length you need to have? For instance, I can start a regular EC2 and delete it in 2 minutes. What are the limits for Mac OS? Is it the same, or hour, or day, or month?
Yeah, so I can share, let me quickly share my screen. 1 second. Okay, let me quickly share my screen. So this is a quick overview of just the details around Mac OS, how EC2 Macs work. So as I mentioned, the main caveat here when we talk in comparison to other type of EC2 machines is the is the minimum 24-hour allocation. So this is something to keep in mind. Currently, there are 2 general purpose instances available. So there are x86 type machines, so Intel-based Macs, and M1 is has been recently announced. This is under Mac 2 types. You can SSH to it. You can SSH to those machines. You can use VNC for GUI or PC over IP agents if you're using things like Teradici or similar solution. Yeah, and that's about it. So we have to remember there's some caveats. Mainly, this is just how Apple does their licensing, but we still have the benefits of leveraging the scalability and elasticity that EC2 brings to the table when we talk about Mac OS machines.
Yeah, and to add on to that, a lot of people will sit there, even myself included. I sat there and I was like, if I'm an individual developer on my Mac machine, is this something that would be cost effective for me? And obviously it wouldn't for an individual. Now, when the company that I was working with, they had 1,000 developers. So if I take 1,000 developers and I need to purchase a Mac machine for every one of those developers, I end up in a situation where 1,000 times a $2,500 machine, then multiplying that times for JMF, for MDM, for all of the other things that go into having that machine provisioned for a user and then updating it every 2 years, that becomes almost where at 1,000 users, we did the math for the calculation. And it was going to save them about, it was going to save them roughly $500,000 a year just in having those instances available, even though they have to run a day at a time. Other things that we showed them how to do are having things like, hey, you know what? If nobody's going to be building on the weekends or nobody's going to be working on the weekends, great. Well, you know what? At Friday at 5 o'clock, we'll go ahead and shut them down and we can save 2 days over the weekend. Whatever that looks like, because it is that 24-hour rolling window, being able to know when you provision and when you stop is going to be important. But if you're really interested in that amount of cost savings, some of the things that you're going to get through consistency and reuse are going to outweigh the cost implications.
All righty. Thank you so much, Lee and Mark. We do have a few more questions, but at this point, they do start getting a bit more specific. So we're just going to keep on going. So are there any implications or considerations for enterprise JMF users?
From an AWS perspective, I shared a blog post that some of my colleagues did about running JMF on EC2 Macs. So I will also resend the link in the chat, and people can have a look there and see.
All right. This next one reads, we use App Center for building Android and iOS apps in React Native. Do you recommend this method, using Mac instances and Linux instances using tags in my CI file?
I would recommend doing that. So even though React Native should go ahead and work across both devices, the one thing that you're going to want to make sure that you do is you're going to want to make sure that you're building specifically with a target. So I can do testing. So when I go ahead, if I'm going to use something like AWS Device Farm for my testing, even with my React Native applications, I want to make sure that I create an IPA for me to be able to deploy that particular application into Device Farm. And then the same thing on the Android side, you're going to want to create an Android APK that you can go ahead and deploy into Device Farm as well. And that way you can get all of your testing across React Native across both of those. But you're going to want to have specific. This way you can build your Android on one target, build your iOS on another target, and be able to make sure that you're getting the right outputs for Device Farm for your testing.
All right, thank you both. Have you done any Unity builds with this? We do lots of Unity cross-platform, but need Mac for iPad.
Wow, that's a great question. I have not done that, but I could see it working the same way. It really depends. I can imagine, I don't know about you, Mark, but doing a Unity build, I would say it would not be a good idea to virtualize the Mac. Sure. I would be using the raw and using a shell type configuration. So that way you can take advantage of all the resources. The one thing to realize is that Mac instance is a bare metal Mac box. So you're getting all of the benefits as if you had a Mac Mini running next to you. It's just running in the cloud.
Yeah, so I did hear about some customers who are doing something very similar around Unity. I don't have the exact details, unfortunately. But theoretically, as you mentioned, Lee, whatever you can do on a Mac Mini, that you have a physical Mac Mini that you have beside you, you can do also an EC2 Mac. And again, with some restrictions, again, as we mentioned, I wouldn't run Unity builds on virtualized. I don't think it's possible. I'm not sure. So also something to keep in mind.
All right, and it looks like we are down to our final question. So here is my final reminder for the audience to send in any questions you may have, and we'll try to squeeze them in here toward the end. So would it be possible to provision a Mac fleet with pre-configured SSH keys with no manual actions at all?
So I've sent the JamF blog, and the JamF blog does go over around how to automate the initialization phase of the Mac OS, so how to bring it up without manual steps. And also what Lee showed today, this can also be some sort of a script that you can build in most cases to automate the installation of parallels, to automate the creation of the smaller virtual machines if you need them. And of course, you can have the pre-configured AMI in case you want to use the entire machine with all your tools and all your softwares and all your software chain that you need for the development.
All right, so it does seem that we have exhausted our questions. So I do want to give each of you an opportunity to give any closing words or anything you think the audience absolutely needs to take away from this session today.
So I'll start. I want to thank everybody for attending. One of the things that I've realized by going through and building this out is my iOS development experience is pretty minimal. But it has really intrigued me to want to learn more. And I know I have just scratched the surface. Knowing that I can have an automated build system on the back end that gives me the ability to be able to share my work and my best practices and things as I'm going over time, especially with things like Git and GitLab. I am very encouraged to go off and build a production app store application. If anybody has any ideas for that $1 million idea, I'm ready to go. So, definitely, I think this is the way that most of our customers are going to be moving. We're hearing a lot of our customers today talking about efficiencies and things as we're going through somewhat of a downturn in the economy around the globe. People are looking at better ways of doing things, how to reuse relationships that they already have. I don't think Mark and I have mentioned, like, these Mac instances will still come off of your commit. They'll come off of your spend. So this is not one of those things that you have to worry about having a separate budget item off of. So if you've already got a relationship with AWS and you've already got spend that you need to use, this is a great way to go off and be able to use up some of those resources.
Yeah, that's a great point, Lee, and thank you for that. And again, thank you for everybody else that joined us today. I'm really happy that we had this opportunity to talk about pipelines with mobile development and macOS development with GitLab on AWS. And I encourage everybody to read more about Device Farm and EC2 on Mac, and actually try and recreate what we did here on GitLab. I think it's a very good opportunity to, as Lee mentioned, streamline some activities and some pipelines that we already have, and show improvement in efficiency and empower developers. So thank you.
Well, Mark and Lee, thank you both for joining us. I did actually just receive a question for myself, so it's a great time to remind everyone that this session was recorded. So you will be receiving an email with a link to access this recording on demand, or you can find the recording living on the DevOps website at devops.com/webinars. So we do still have those 4 $25 Amazon gift cards to give out. Our winners are Samantha F., Jordan T., Shelby T., and Cheryl A. So to our 4 winners, please keep an eye on your inbox to claim your gift card. And if you don't happen to see that email, do check your spam folder. Lee, Mark, thank you both. I'd like to thank AWS and GitLab for sponsoring today's program. And to our audience who's been with us for the past hour, thank you so much for spending your time with us here. We really value your time, and we also really value your feedback. So as soon as we close out, there will be a survey that will pop up on your screen. We'd really appreciate your feedback. Let us know what you liked about today's program, or maybe what you'd like to see on a future program. Otherwise, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and Mark, Lee, thank you both.
Thank you.